Hello everyone, this is an example of the double line diagram. This is just another way to express ratios. You might see that we have a ratio right here, 4 to 7, 8 to 14, 12 to 21. Those are three equivalent ratios. We could also write those in a table, 4 to 7, 8 to 14, and 12 to 21. We could have put them in a table like that. But the thing about the tables is the tables we mostly use for whole numbers. And this is a diagram that we're going to start using when we have fractions. So, for instance, this table would work great if I said, we're going to find a ratio that is 16 to some number that is equivalent to this ratio 4 to 7. Well, you could do the additive method, and you could just see that you're counting by sevens, and so that would be 28. Simple. So you could use it for that, but that's not what we're going to be using it for. What we use it for is for kind of more difficult problems. So let's say that we have 11. So here we have 11. Now, this one's challenging because, remember we're not teaching them how to, multiply 4 times some number to get 7. So we're thinking, well, now that we're in between numbers right here, now that we're in between all these numbers, we don't necessarily know that this number is going to be a whole number. It could be in between some number. But there's a few things that this diagram helps us do. First, it helps us see that 11 is closer to 12 than it is to 8. So whatever this is, that should be closer to 21 than to 14. When we're dealing with fractions, that can be super helpful for kids that are struggling with the concept of fractions. So let me stop chatting, and this is how we would use this to solve a ratio problem. So basically what we're doing is we're trying to see, we know that we have 11, and where is 11 in relation to other numbers? Well, I see that 11 is between 8 and 12, and it is 3/4 of the way between, 11 is 3/4 of the way between 8 and 12. So we have, so we know it's 3/4 of the way between these two numbers, and that's important because if 11 is 3/4 of the way between 8 and 12, then the other number we're trying to find is also going to be 3/4 of the way between these numbers, the numbers that are equivalent to 8 and 12 for their respective ratios. So what is 3/4 of the way between 14 and 21? Well, we need to think about, what is between 14 and 21? What is this representing? Well, that's representing 7, right? There's 7 between 14 and 21. So we really have 3/4 of 7. So we're going to do 3/4 times 7. That would be 21 over 4, which is 5 1/4. So again, we're just trying to find out what 3/4 of the way of this is, and that ends up being 5 1/4 because we're finding essentially 3/4 of 7. Okay, now that we know that, we need to add this number to 14 because we're really trying to find what's right. Remember, we're trying to find what's right here, and that is 14 plus whatever that 3/4 was. So I need to find, since I'm trying to look for what's right there, I'm doing 14 plus 5 1/4. That's going to give me 19 1/4. And we're close to the answer, but remember we're trying to find the ratio. So we found this number right here, but we need to write it in relation to our ratio. So the final answer would be 11 to 19 and 1/4. So that's, you just have to end up writing it like that. And basically what we're getting at is this is an equivalent ratio to this ratio and all the other ones. So here's another example. Let's say that we're trying to find 34. So we have 34 right here. What number would make an equivalent ratio of, we have down here we have 6 to 20, the most basic version of that. The rate of that would be, as a fraction, it would be 3 to 10. So what is equivalent to 3 to 10 if we have 34 to something else? Well, so let's figure out how far this is between here. Well, it looks like it's 1, 2, 3, 4, 5, 6. It looks like it's 4/6 of the. Looks like 34 is 4/6 of the way from 30 to 36. So I'm gonna write that down. 4/6, and I want to find out then 1, 2, 3, 4, 5, 6. What is 4/6 of this? What's 4/6 of that? That's 20. So I'm going to do 4/6 of 20. That's going to give me 80/6, which is equal to 13 3/6, or 13 1/2. So I can take that then, since I know that 13 1/2, this right here, 13 1/2 is this distance right here. I can add that to 100, so I can do 100 plus 13 1/2, and that gives me, I'll write it off to the side, 113 1/2. So that would be all of that, right? And remember that I'm writing the ratio, all that. So I really need to write it as 34 to 113 1/2. And that would be the answer.